Okay, we're going to get started with Unit 14. Today we're focusing on the t-distribution. Before we move forward, we're just going to review some of the key symbols that we're going to be using. First of all, the symbol mu, that represents the mean of the population. So it's the mean of all the objects that are under study. X bar is the sample mean, so if we take a sample from the population and compute the mean of just that sample, we have X bar. Sigma is the population standard deviation. S, sample standard deviation. N is the sample size. Okay. So for most confidence intervals, the population standard deviation will not be known. Thus, the distribution used to estimate the population mean will most likely not be normal. The t-distribution will be used in place of the normal distribution when sigma is unknown. Let's talk a little bit about the t-distribution. Well, the t-distribution was discovered by William S. Gossett in 1908. He was a statistician employed by Guinness Brewery who was not allowed to use his name when publishing his discovery. Thus, he used the pseudonym Student, and his distribution was known as Student's t-distribution. Over time, the word student was dropped, and now we just call it a t-distribution. And the t-distribution is graphed below. We're going to look at some of the key properties. So for the t-distribution, it is symmetric about the mean, which is 0. The mean, median, and mode are all located at the center of the distribution. The graph never touches the horizontal axis. It gets very close to it, but never touches it. The variance, though, is greater than 1, so that's a difference in comparison to the normal distribution. Another difference is the distribution is not just one curve, it's actually a family of curves. And that's kind of represented here. This family of curves depends on a concept called degrees of freedom. That's going to be n minus 1. So for each degrees of freedom, you'll have a different graph for the t-distribution. However, as the degrees of freedom increases, the t-distribution will evolve into a normal distribution. In fact, once the sample size n is 30 plus, it's practically a normal distribution. So how do we know when to use the t-distribution? Well, for each problem we work on, we always ask ourselves, is the population standard deviation known? If the answer is yes, we use z-values. If the answer is no, we'll use t-values. So let's look at how to locate t-values. So the process to find a t-value, which is denoted as t sub alpha over 2, we perform the following steps. First, we compute our degrees of freedom. It's always n minus 1, sample size minus 1. Then we're going to look up our t-value in table F using the confidence level and the degrees of freedom. Here's an example. Find the t-value when the sample size is 10 and the confidence level is 90%. Compute degrees of freedom. 10 minus 1 is 9. And we go to our confidence level 90%, go down to 9. We have our t-value, 1.833. So that would be the t-value. We have a couple of other examples here. So let's say the confidence level is 95%, sample size is 28. First compute degrees of freedom, 28 minus 1, 27. Then we go to table F, and we're going to look up the t-value. So let me just, it's 95%. So we go to 95% and we go down to 9. Actually to 27, so let's go back. So we go down to 27, so 2.052. see, I just want to make sure. Go back, so 95% down to 27, and that should be 2.052. Yes, and that's our t-value. Now, if the confidence level is 99%, the sample size is 50, 50 minus 1 is 49. Well, if you notice, we look at our table, 49 is not listed here. There's gaps between the numbers. So even though 50 is closer to 49, we go smaller, go to 45, and we're looking for 99% confidence level, so it's going to be 2.69. All right, so let me just recheck that again. So 45, 99% should be 2.69, so we have a correction here. 2.69. Let me just double check that value. Yes, 2.690 would be the t-value. Okay. The formula for the confidence interval for the mean when sigma is unknown is the following. It's similar to the previous formula. We're just adding and subtracting the margin of error from our sample mean, except that now we're not using c values, we're using t values. Also, sigma is unknown, so we've replaced it with s. So let's take a look at an example. Assume that for a random sample of 10 used smartphones sold in the San Gabriel Valley, the average price is $240. Sample standard deviation, so that's the key right there, sample standard deviation. That lets us know that we have S, not sigma. Find the 90% confidence interval for the true mean price of all the smartphones sold in the San Gabriel Valley. Those are used smartphones. So let's go ahead and label our items. Mu is unknown, we're estimating this value. X bar is 240. That was the average of the 10 used iPhones. Sigma's not given, right? We're only given the sample standard deviation, S, and that's 33. N is 10, so we have a sample of 10 used iPhones. Next, we have to find the t-values, so we compute degrees of freedom, 10 minus 1, since we have 10 phones, that's 9. We look up our value in table F like we did previously, 1.833. We take this information and we plug it into our formula and calculate. So X bar is 240, T is 1.833, S is 33, N is 10. Somewhat symmetrical on the opposite side. We perform our calculations, and then we can see that the true price of used cell phones is somewhere between 220.87 and 259.13. And that's how we do our calculation. I have a couple of problems for you to try. Now, for problem 2, I give you a set of data values. I'm going to make a video to show you how to compute the mean and standard deviation using your calculator. Because some of the problems in these sections, they require you to use your calculator. You could use the formulas that were provided in Chapter 3, but it gets a little cumbersome to constantly use that formula when you can simply type in these values into your calculator and just hit a button, and it'll just compute the mean and standard deviation for you. But we're going to take a look at one more problem. Okay, here's our last example for this section. Assume that the entire population of employees at Atlas Realty in Northridge, California is 50 employees. Use the t-distribution to estimate the average age of all employees with a 95% confidence level. We select a random sample of 9 ages, and we are going to compare the actual mean. The actual mean is 44 with the result that we compute. Well, we have our 9 ages. So, as I said before, you're going to use your calculator, and I'll show you how to do that later on in another video. You're going to use your calculator to type in these values and produce these statistics here. N is 9, that's just the number of values. The mean is 43.2 and standard deviation is 11.74. Since sigma is unknown, we're only given S. Anytime you have to do a calculation, that's S. Compute degrees of freedom. 9 minus 1 is not, that should be 8. Then we're going to look up our critical value in our table. So let's do that right now. So we go to we're going to go to 8, and what was the confidence level? So the confidence level was 95%. So 95% go down to 8 should be 2.306. So that means our Z value should be our T value should be 2.306. We're going to plug that into our formula, and we'll get the answer. And just need to do some quick calculations, and we're going to get that answer right. Okay, so the T value we found was 2.306. So now we're going to take all our data values and insert it into our formula. Means 43.2, T value 2.306, S is 11.74, N is 9. Perform our calculations, and we end up with the confidence interval is somewhere, the mean is going to be somewhere between 34.18 and 52.22. And if you recall, in the problem it stated that the actual mean is 44, so this shows that 44 is actually captured by our confidence interval. And that's how we compute confidence intervals when sigma is unknown.